Okay, this is lesson 5.6, part 2, and in this example we're going to look at another application question. So this is similar to an application question that we've done previously. Let's dive right in. Find an algebraic expression for the area of the remaining area if you were to remove the smaller square, so this white square, from the larger square, this filled in gray square. So we want to know the area remaining. If we had the area of the large square and we subtracted the area of the small square. Well, what's the area of the large square? Well, since it's a square, it's just this one side squared. So it would be 3x plus 8 squared, because remember length times width for area of a rectangle, but if they're the same, you just square it. And the small would be similar. It would just be x minus 2 squared. What's neat is this is a difference of squares, because we have a bracket squared, subtract a bracket squared. We have something squared minus something squared. But the first part just asks us to find an algebraic expression. Well, this is an algebraic expression, so we could say that that's the end. If we wanted to, we could expand this, collect like terms, and find another algebraic expression. It doesn't tell us what specific type of algebraic expression to find. But this is an acceptable final answer because that's an algebraic expression, letters and numbers. If it said expanded or simplified algebraic expression, you could argue that this is simplified. But if it said expanded, we'd have to expand. Now, you could expand as some good practice, but I'm just going to say expand to save us some time. And I'm going to write the answer to what we would get if we expanded. If we expanded this whole thing, we'd end up with 8x squared plus 52x plus 60. And that would also be an acceptable final answer. Now, if you want to see how to expand this, you can check the posted solution on the course website. It shows the full expansion. But for our purposes, we're just going to identify this as our algebraic expression. If we wanted to, we could add this. Now, we're going to write the expression in factored form. So we're going to start with both of these. We're going to use this expression, and we're going to get both to factored form. So our first one was 3x plus 8 squared minus x minus 2 squared. Or if we'd expanded, we'd have this. And neither of these are factored. You know something's factored when it's something times something times something. And this is close. This is something squared minus something squared, but there's this minus sign in the middle. So we know it's not factored because we have two terms. This has three terms. This is a trinomial, so this isn't factored either. Let's start with the one on the left and factor it. Well, since we have a difference of squares, I'm going to make this fairly easy. I'm just going to say and let's pick a letter. Let A equal 3x plus 8. And let B equal x minus 2. So we're going to let A be that first bracket. We're going to let B be that second bracket. And then you can see that we really just have A squared minus B squared, which is just a difference of squares. And if you remember how to factor a difference of squares, it's two brackets. And we get A plus B and A minus B. Well, now, since it's factored, we can just write back in what A and B are. Well, A was 3x plus 8, and B was x minus 2. A is 3x plus 8, and B is x minus 2. So now in each bracket, we're just going to open up this bracket and collect like terms. 3x plus 8, and we're going to add x, so plus x, and we're going to add negative 2, so subtract 2. Second bracket's a little trickier, 3x plus 8. We're going to subtract an x, so minus x, and we're going to subtract a negative 2, so plus 2. And now we can collect like terms. 3x and x gives us 4x, and 8 minus 2 is 6. 3x minus x is 2x. And 8 plus 2 is 10. And now we have something here. We have what looks like factored form, except this isn't fully factored. Because if you look in each bracket, we have something common. 4x and 6 have something in common, and that's 2. So we have a 2 that's common. And in this bracket, we also have a 2 that's common. So we have to common factor those 2's out. Well, where do we put them? We put them at the front. Now we have 2 times 2 times 2x plus 3 and x plus 5. And what's 2 times 2? 2 times 2 is 4. And now we have fully factored. That was complicated. If we had expanded, we would have had this. This might be easier to factor because it's just a complex trinomial. There's a greatest common factor. All those numbers can divide by 4. And we'd be left with 2x squared plus 13x plus 15. And now we'd look for numbers that multiply to a times c and add to b. Well, we want them to add to 13, and multiply to a times c is 30. Well, what multiplies to 30 and adds to 13? 10 and 3. So now if we remember our lesson 5.5, we would do decomposition. We would break down that middle term into 10x and 3x. And now we would group and common factor. What's common to these two? 2x. And we'd be left with x plus 5. What's common to these two? 3. And we'd be left with x plus 5. X plus 5 is now our common bracket. And 2x plus 3 is what's left over. And there we have in 4 lines factored form. Whereas over here, we used many more than 4 lines, in fact double, 8 lines to get to our final answer. So 2 different ways to factor. If we have a difference of squares, we can factor using the difference of squares property. And if we have a complex trinomial, we can factor like a complex trinomial. So that's it for our quadratics application question. And actually that's it for Unit 5. Thanks for watching, and I'll see you in Unit 6.